and welcome everybody. I'm super happy that so many people are here in that room. Also, a huge welcome to the remote people. It's so nice that everybody is watching us today. To introduce myself, I'm Bernadette. I'm the assistant of Kobi today, who hosts the session. Thank you for being here. I'm basically here to check if there are questions popping up in the chat, so that is really important for the remote people. I guess you know how it works already. Just type in your questions, and during the session, we will, I'm gonna read it to you, and then we will definitely find an answer to the questions. So it is really important for you as well. For the people here in the room, just raise your hand if you do have a question, even during the sessions, and I come over, I hand you the microphone, and then you're able to ask. So, have fun, enjoy the session, and just have a good time. Thank you.
Thank you. Thank you very much. First of all, I'd like to thank SNS Media for having this format. I'm very, very excited to get back on stage. It's the first time for me in DevOpsCon. I live in Munich, so it's great. Thank you for showing up and staying up till the end of the day. I know, these are this is the last slot for the sessions, which is really great. So I don't take that for granted. Thank you very much. So today we're going to talk about few Kubernetes decisions. My name is Kobi Biton. I'm a specialist solution architect working for 9 years-ish. With AWS. Specifically now I work in AWS in covering the DACH area. But my session is not going to be focused on specifically on AWS. I decided to do that session simply because I work with few strategic customers, and we've been such a lot over the last year trying to modernize their applications, and specifically running Kubernetes clusters, making critical design, paramount and critical design decisions where in the critical path, and I always been there with them on the critical path, and I decided to share that. Of course, no customer names, just those particular decisions. One more reason I decided to create that session is the slide you just see. For those of you who are not familiar, this is how the CNCF looks now. The CNCF project landscape, right? And when I talk to my customers, this is the first slide I show them, right? Confusion, right? No one actually see how many projects, what is graduated, what is incubating, and CNCF became really something that it's pretty hard to track in terms of, if you want to adopt some kind of a CSI driver, wow, that's the plethora of tools. Of course, there are always the ones which are core projects and graduated projects, which are easier, but I think the point is taken here. A little bit about me. That's me when I was 5 years old. It's a true picture. About 20 years in the industry, about 8-9 years in AWS, spending a lot of time as a solution architect and managing solution architecture teams, working with strategic customers nowadays. And you can see my blog. This is the blog I write things. My personal blog, and I write also to the AWS containers blog. I normally write about application modernization, distributed systems, etc. And of course, I'm a very proud father to kids and a proud husband. So this is the first thing I show my customers when I start the initial meeting. They ask me, what's your job? What is a specialist solution architect? So that's kind of describes my role, right? So the customer or the partner that I work with is in the front seat, taking the wheel, right? Or the stick, if you wish. And I'm the navigator, right? I'm behind the scene. I'm supposed to give some guidance, but the handle is always in the customer hands. I'm not going to do an agenda slide, sorry. I don't like those, right? So this is how the session is going to be built. And this is the logical structure. We're going to have between 5 or 6 decisions. We're going to have the decision. We're going to have a graphic. Don't throw tomatoes on me. I created those graphics, right? So hopefully you'll find them amusing. And they are supposed to manifestate the decision dilemma, or at least what I was thinking that I relay through those graphics. And there is a slide called questions. Not questions for you, of course, you can ask any time, but these are questions you will need to ask yourself when you're facing that particular decision fork or dilemma. I'm not going to show best practices here, because those can be found anywhere and are very different between customer to customer. And then I'm going to present a slide for each decision, patterns and anti-patterns or considerations. These are all from the field that I worked with my customers that chose to implement X, and then there were some things that we saw that work well. Some of them became anti-patterns, really, and impacted the customer quite significantly. This is how I see Kubernetes today. It's an orchestrator, but it's really a microcosmos, right? Once you install that, right, you have this like special microcosmos. And nowadays, everybody thinks that it's going to solve the world hunger or all the problems on the planet, right? This is just something that I was amused with. I came up with that yesterday before the sessions, right? No, your doctor is not going to give you Kubernetes and you're going to feel better, right? So sometimes I think we are overrating and we're obsessed with the next version and versus stability and looking at the outer picture a little bit. Because every application, whether it's containerized or not, still needs to have storage, security, databases, interconnectivity with on-premise or other cloud providers. And somehow I see customers who are forgetting that and jump into the Kubernetes pool immediately. So I'm here to give a little bit of a macro perspective. The first decision with my customers is multi-tenancy in Kubernetes. I work with a lot of SaaS providers or customers who even have internal customers in their organization. But you gotta be kidding me with multi-tenancy when it comes to Kubernetes. Why do I think that why did I write you gotta be kidding me? This is the first slide I show to CTOs when they're going to modernize their SaaS service on Kubernetes. And I find it really surprised how many times I need to explain that Kubernetes is a single tenant orchestrator. And natively, if you want to run something isolated, it's pretty hard. Because, as you can see, even if you do namespace isolation with network policies, whatnot, still, Kubernetes, data plane, and containers are really process-level isolation. And process-level isolation is not a strong security isolation. If you have an application that can exploit the process and do an inter-process tapping or attack, you could attack a neighbor or a tenant with a different container on the same node, right? So that needs to be taken into consideration. We'll talk a little bit about, in a while, what can you do to mitigate that. But it's very important that the organization will understand that this is merely a process-level isolation. Control plane. The control plane is not divided into virtual tenant. It was never planned to be like that. So everything that you can isolate on the control plane level will be what I refer as soft isolation. Whether you're using RBAC policies, permissions for pods, etc. These are only configuration, but still the scheduler and the controllers that run on the control plane share the same data, all the data plane shares the same processes. And this is how Kubernetes was planned from day one. So what questions do you need to ask yourself if you're going to run a multi-tenant shared workload on the cluster? I'm amazed of how much people do I see in the organization which do not ask this simple yet super important question. And what is the application and service is actually doing? Because there's a lot of time it says, okay, I have this application from the developer teams, but wait a minute. What kind of permission, what kind of Linux capabilities do you need to mount host volumes? And a lot of time, just having that particular matrix that says, this is the application, this is the privilege, this is the Linux capabilities that the application needs, this is the process capabilities. Let's start there. And trust me, when you start there, you can identify really fast the application that you're going to have challenged with them when it comes to permissions and capabilities. So let's first try to understand. Let's understand the use case. Do you control the tenants or completely untrusted tenant outside your control? These are very critical questions to ask during the design phase. What is the tenant dimension? In a SaaS, every tenant needs to have some kind of a dimension. When customers are modernizing SaaS platforms, I do see them coming from silos, monolith with silos, so every customer had this particular silo, into a shared tenancy. That's a completely paradigm shift. If your application cannot start the isolation on the application level, tenant ID, identity, etc., don't even go to Kubernetes yet, right? Or just have dedicated clusters. That's not your solution. So you first need to think on the application, whether it's capable on creating a multi-tenant environment. And it's hard. I've seen many customers taking their unprepared application into a shared tenancy environment and suffer from security outages just because. So it's very important, and I can also take that with every one of you here offline, analyzing their use case. Ask how many tenants you need to support. It's going to be hundreds, thousands. If it's going to be 10 tenants, you might wrap it up with 10 clusters and some kind of a GitOps and IAC implementation, and then you're good. Don't have to have this whole headache of running multi-tenant. But if you're going to have thousands of tenants or hundreds of tenants, it's a different ball game. Ask about the data store that your application will need to access. Normally, data stores will be shared, and they also need tenancy to make sure that data cannot be exploited by attackers. I often see developers just load, some Python libraries and access the Kubernetes API from the application. A big no-no. In a multi-tenant environment, if your application needs to access a specific Kubernetes API construct, I highly recommend you to have a layer that the application can only access that particular layer. As I said, because the control plane was not built as a multi-tenant in mind, that could be used to exploit other customers' names, IDs, etc., through kubelet with other nodes as well. So your application needs to access what you want it to access, an API that to implement, and behind that API there is the Kubernetes API. Highly recommend to start there. Now I want to talk about 3 models that I see with other customers and that I help customer design as well. I keep my customers asking those hard questions. So if you have an untrusted workload, that's where you should go, dedicated. I'm sorry to let you down. What is an untrusted workload, you're probably asking me. I had a customer which allowed his customers to run untrusted code in specific containers to do some testing. This is untrusted tenant, because that code can exploit the host to do a vertical attack or a lateral move. If that's the case, I categorize it normally as an untrusted. Now, it could be that in 2 years, the application will be so matured that you will not need those capabilities anymore, and you can build some kind of a sandbox environment, right, for that. But this is untrusted. That's one example. So in untrusted, you go with a dedicated. But sometimes, your environment doesn't need to run untrusted code, and you just want to isolate the tenant softly into a specific node. That's very easy in Kubernetes. It's a solved problem, right? You just do an affinity, but you solve only one thing. You solve the process isolation, right? The inter-process communication. Kubernetes still shares the same network namespace. So if someone exploits that particular node, he can move laterally. So there are mitigation strategies for that, runtime protections, network policies, etc. That works. But just remember to understand that even if you are isolating nodes into specific namespace and specific nodes, you solve the inter-process problem, right? The process isolation, but not necessarily the other challenges. But it's better than nothing. So I call the trusted with soft isolation. The third model is the trusted model. You may have some very busy APIs, your SaaS service, and your application is modernized, and you did a lot of work to create tenant ID, identity providing, and are using all the good things that we'll see when you're doing shared tenancy with Kubernetes. So these are the roughly high-level 3 models that I see when we talk about customers and multi-tenancy. What patterns and anti-patterns I see in those designs? Pattern, hard segregate, untrusted tenants. We talked about that. Node group is a soft isolation, not more than that. I know you might think it's physical, but at the end of the day, I refer it as a soft isolation. You have to start thinking about application-level isolation. Tenant ID, logging, controls, and policies still within their application, not service mesh and layer 7. That's another layer in a defense in depth. So if a tenant with an ID trying to access an application data that he shouldn't access, it shouldn't be blocked on the Kubernetes or layer 7 level or the slash path. No, that should, your application should not serve that particular content, period. That's the first level line of defense. And you should not neglect in any environment, whether it's trusted or untrusted, you always should implement network policies. Policy as a code engine, right? Like OPA or Kyverno, making sure that teams are not able or people are not able to elevate permissions when they're using the Kubernetes APIs. Runtime protections, and I'm going to talk really briefly about runtime protection. Basically, I have a lot of customers that says, hey, I'm a Linux and App Armor master. Don't get there. That's a deep rabbit hole. It's very hard to configure those environments when it comes to containers that needs capabilities. It can break, and it can be very frustrating. All those runtime third-party companies, and I'm not advertising any name here, I'm just saying they have a pretty strong, normally, technologies that can do horizontally, that can detect that something is really going wrong when someone tries to exit or escape a container. And for you, it's going to be pretty hard to implement that using the controls of the operating system and even to maintain that. Super important. Layer 7 filter firewalls. This is also something that you need to implement if you can. And of course, at the end of the day, some cloud providers allow compute isolation. In AWS, for example, we use Fargate for that. Fargate behind the scene means that every container, every pod that you launch is a dedicated EC2 behind the scene. So if you need 500 pods, it's 500 instances for us behind the scene. And that's the best isolation you can think of. It's a VM level isolation. And sometimes I find customers says, hey, you know what? I'll start that particular workload with Fargate because I don't want to create all that particular compute level isolation. Anti-patterns, don't bring the old into the new, please. I've seen customers trying to create OpenVPN servers on Kubernetes. It works, but then you have to do a privilege, and the OpenVPN process will have a full access to the network namespace of the host. And you know what does it mean if someone exploits that, right? He can tap into the network to all your tenants and see all the data. Just don't do that. That wasn't the plan when Kubernetes was born in that sense. Traditional network segmentation as isolation. I see a lot of enterprise organizations come with the paradigm of VLANs and segregation. It doesn't work in Kubernetes. Still, if you do those segregations, you can still exploit. It's a flat networking model, don't forget. Right? The host still shares, all the pods still share the same network namespace. And you have to explain that to those network engineers, which I love them and great, but they are looking from a different perspective. They think that putting another interface will make them more secured in Kubernetes. That's not the case in most times, right? So the thinking should be top to bottom and not bottom to top, always. Shared tenancy on the same cluster if you are PaaS operators is a super anti-pattern. If you let others create things inside your containers, which are privileged in terms of processors, that cannot go into a shared platform, if you ask my opinion. That should be a dedicated cluster for that purpose. Because PaaS platforms normally allow very, very extensive capabilities on the underlying host that they are running. Next decision. How many clusters? How many of you have asked that question already? So lots of small clusters or fewer large clusters. I'm not going to solve your problem here, right? I was just, because I know that this is a question I get quite a lot. And I know why I get that a lot, and I understand why I get that a lot. I get that question a lot because it's easier today to create clusters and to do isolation boundaries when it was Kubernetes 4 or 5 years ago, right? Because you remember those first day installers, it was horrible to install Kubernetes. Nowadays, you got a Terraform template, you have cluster APIs, even cross-plane, oh my God. You know, everything is becoming infrastructure as a code, causes the infrastructure. In a single button, you can create hundreds of clusters nowadays. But do you need those? I don't know. So I suggest to sit with your organization and your architects and to draw that particular table and to think and to ask the following questions. At the minimum, separate your environments when it comes to test or dev environment. Thank you. Okay. Dankeschön. So first, at minimum, separate clusters per environment. That's my first recommendation. Second, ask yourself, did I analyze the constraints in my organization? Do I have untrusted tenants? We talked about that. Untrusted tenants, it's a separated cluster, period. What is my organizational boundaries and areas of concern? Yes, you might have a certain area in your organization that needs to be isolated because that particular area is a very sensitive customer with sensitive data, and you want to have a unit of deployment for that particular customer. That mandates often isolation. I wouldn't say that you don't need to fight against that, because many clusters means much more overhead. So you need to ask the hard questions. Why do we need to segregate that customer? What is the reason? Optimize. The second step would be to optimize within the constraints and try to bring it to the minimum possible, not compromising on security or business needs for unit of deployment and isolation. Because fewer clusters, I've seen that it's proven with data points with my customers. Fewer clusters, it's a better bean packing. When you get the handle to create multiple clusters, you pay more. You are less efficient, period. So challenge a great number of clusters if you don't need that great number of clusters. And that table will give you some kind of rough start of discussion. What happens when you're using, what will have the dimension, for example, when it comes to cost efficiency, you can see that fewer clusters have much better cost efficiency. But you see the application security and resilience, their blast radius is much higher. So if you have 200 tenants there, and that cluster goes away because you didn't do a blue-green deployment for your next 125 version, then you got a major downtime. That's also a consideration. So some patterns I see here and anti-patterns. Business constraint analysis, a check, must be done. Blast radius unit of deployment. If you are in the SaaS tenancy, you might say, for me, a unit of deployment means 4 customers, 5 customers, 3 node groups, and 3 databases, and then you define this unit of deployment, and you know the blast radius, and you can give the organization a blast radius from day one. This is amazing. Then the organization can do the risk analysis and say, okay, I can live with that blast radius. And then you can do the networking design, how many IPs, how many pods I'm going to have there. Much easier than working, from the end, and in that particular sense. So I would say one sentence: split when you have to, merge where you can. That's my mantra when I come to how many clusters. And there's no one good answer here, right? There's always a use case that you have to, but that should give you some pretty good start here. And I wouldn't start talking about multiple clusters if I don't have the 4th bullet already really implemented inside our organization. That is proper operational mechanisms to generate those multiple clusters. It's not easy, folks, still. Yeah, it's much easier. You got Terraform today, Pulumi, of course, Argus, the great Argus CD, Crossplane. These are all great tools. But if you don't have those already implemented, these are also cultures, it will be very hard, as I call it, to take care of clusters in day 2. To provision, yeah, but you wake up in the morning, you already have the cluster provision, now day 2 starts. How do I manage those things? How do I update resources, etc., right? No worries about the deck. It's going to be shared, so no worries there. How many of you are encrypting in-cluster traffic throughout the microservices here? How many is using MTLS here? Service mesh? Okay. That's also a tough one. So this is my take, what I see for most of my customers. This is what you want, right? You might have a CISO that comes and says, hey, we also need to encrypt in transit here. So I want all the pod-to-pod communication encrypted, service-to-service communication, whatnot. And then you say, OK, let me go to the whiteboard. Let me start to design and understand what the ecosystem has to offer. Surprise, it's not going to be easy. You start with that requirement, and you end up like this, right? I'm going to leave the slide for 10 seconds here. Now, that's not a bad thing to end up with, right? Service mesh, I think one of the ingenuity in Istio or in any service mesh, they understood the gap in mutual TLS. And they said, we're going to give you a lot of an ecosystem here that will allow you to create certificate authorities, issue keys, rotate certificate, etc. But it might not what you want to end up here. You just wanted encryption, and you ended up installing a service mesh. This will work really well. But I would argue that if you just needed encryption, that might be a little bit of an overkill. And it will meet you when you need to interconnect clusters. Interconnect cluster with service meshes, it's complex, folks. So before you jump into service mesh, which is a great solution for different other issues, right? Additional, right? If you want to route traffic, if you want to isolate, if you want to do a circuit breaking, yeah, I can name a lot. If you want to do blue-green, canary, service discovery that comes normally aligned with a mesh. But mesh is a mess when it comes to connecting meshes together. So if you just wanted encryption, you might do well with that pattern, which I see quite a lot recently. We have a new kid on the block called WireGuard. How many of you have heard about WireGuard? Wow, this is amazing. So I'm in love with WireGuard because I read that Linus Torvalds wrote that this is a work of art. If you compare it to the IPsec and OpenVPN code, right? Of course, if you look at the OpenVPN code, you probably can faint, right? 10,000 of lines. WireGuard is about, I think, if I remember correctly, 4,000 lines of code as a kernel module, which you can encrypt. Kernels 5.1, I think, up north. And we have a new kid on the block called Cilium as well. I'm sure that most of the people here are already aware of the CNI, which is a breakthrough, I think. And I'm not talking about just the eBPF, right? Let's put eBPF aside. I want to open up a side channel for eBPF. One of the cool things I learned is that WireGuard integrates really well with containers and specifically with Cilium. So you can create in, I would say, 15 minutes a cluster with Cilium and WireGuard, which handles the keys for you. Oh man, the public and the private for encryption. And then you get an encryption, a transparent encryption without a PKI. Now, it might not meet your standards because your CISO might come and say, hey, no way, I want my own certificate, make things harder on you. But just try to show them the diagram I showed you earlier. What does it mean to encrypt with MTLS? Or you don't have to do that with service mesh as well. You will have to find a proper packet that will, and that's a headache to find a packet that will also generate keys, rotate, monitor, etc. Not an easy task, folks. So you might end up here or here. That's your choice. If that meets your organizational security policy, that's something definitely to look at. Now, it has some limitation, folks. That's why you have to read the small letters. It's all about understanding what can you solve with that particular technology. Let's see. These are the questions you want to talk with your CISO and your requirements. Am I in an area of zero trust or trust no one? That's the first question. What are my encryption requirements? Right? What are the ciphers? What is the rotation policy? Do I need to use my own keys? Can it be auto-generated keys? Will I implement service mesh just for the MTLS? You might end up. And then say, OK, wait a minute, but it also brings such a lot of other good features that I want to use that. It could be the catalysator for running a service mesh, for sure. Istio is doing that really well, by the way. I call it almost transparent encryption, which is not transparent because behind the scene there's a lot of moving parts. Istio makes it transparent maybe for you, but WireGuard is really transparent encryption. Some cloud providers, I'm sorry, I don't know others in that particular sense, have EC2 instances, or sorry, have compute instances which on the wire will do transparent encryption. In AWS, you have Nitro. Most of the Nitro instances, not all of them, will provide transparent encryption. That might be a quick win for you with your CISO when you go back and talk to him. So, oh, have you seen, if we use the latest EC2 Nitros, that particular type and family, these are encrypted. If it meets the requirement, that's a quick win. It's always better. And you don't sacrifice any performance in that. It's on the cloud backplane. Another super important question to ask that I see that sometimes you get to the implementation phase and then being asked, what is your flows of encryption requirements? Do you need only pod to pod, host to pod, or host to host? This is critical to understand which solution will work for you. Because you might have pods or applications which are not part of the MTLS scheme or not part of the encryption. And you might have the host calling, agent calling an API which is not part of the encryption. So ask those hard questions. For example, to the last time I checked, WireGuard and Cilium still doesn't support anything else than pod to pod at the moment. So they don't support host to pod. They're working on that, though. So that's also something to take into consideration. These are the small letters, right? So pattern, understand the encryption requirements, define the zero trust in practical manner, please. I love, you go to the CISO, it says zero trust. Yeah, but what does it really mean? Can you show me how do we translate zero trust? What? Certificate per device, MTLS, normal TLS. And I'm amazed sometimes, and it may sound weird, when I met MTLS for the first time, it took me some time to understand what is the difference between TLS and MTLS. I know that all the people here probably know that, but you'll be amazed how many people in your organization might not know the difference. So these are also things, first to understand if this is something that you're required to support. Because it's far easier to support TLS, trust me. Right, which you can verify with, of course, public certificate authority than your own. This is a game changer in terms of the effort that you will have to put, right? I'm just going to give a single anti-pattern here. No designated well-known org PACI. If you want to do MTLS in particular, and you don't have a public key infrastructure, think twice. This is the first thing to look how I'm going to manage the keys, the certificates, the private and the public, the signer, the root, the intermediate, and how do I monitor those? That's where you start with that particular design. And then you decide if you go to Istio for that, or if you go to other solutions. Cloud providers also have certificate managers in that sense. Some of them will integrate well with your open source, some of them less. Purpose-built container operating system. How many people here are running CoreOS? Or, well, that's great. How many of you are running the optimized versions of, Linux operating system for containers? The regular ones. Okay. So that's also a decision I tend to talk with my customers. I don't have anything against traditional operation systems, Ubuntu out of the box, etc. They will run containers very efficiently, trust me. But there are a couple of things I want to tell you about those. Got nothing to do with the distro, right? CentOS, Red Hat, security. They have 4 tenets which installing extra packages simply satisfy dependencies will increase the attack surface, I'm sorry. If I don't need that particular library and it sits there, it's a potential CVE. Why? My container has that particular library. Why should I sacrifice that? Second, updates. Traditional package-based update systems are complex and prone to error. How many times you update and you might leave your whole node group in an inconsistent state because the update failed? Yeah, we solved that today with what we call immutability, right? You treat those, if you need, most of the customers I work with, if they need to update something, they simply replace the AMI or whatever we call it in other cloud providers with the latest and greatest. But some of them are actually installing those updates. The overhead of managing updates for operating system is complex and prone to error, and it increases startup times. If your OS has a bigger footprint, it will take more time to boot that particular compute resource. And I talked about drift. It's very easy to get into a drift state until you don't have any other things to do. You have to simply baseline with new images. So these are my concerns when it comes to traditional operation systems. Now, in cloud providers, when they give you those optimized OS, even AWS, these are just optimized as a worker node for Kubernetes. They are not tightly secured, or they are still based on general Linux, and they have a lot of packages that you probably don't need, right? Optimized means that they have user data, bootstrap, that allows you to install the kubelet and successfully register your worker node. But that's about it, right? That's an optimized. The next version of operating system is what I called purpose-built operating system. CoreOS was the first to start that. They did an amazing job. And I call it just enough operation system to run containers. Because containers needs very minimal, right? You need a kernel, you need few core libraries, and that's about it, right? So why have those been created? So AWS created one, it's called BattleRocket. And here is an example on one feature that BattleRocket will provide if you run, or any other, I would say, probably any other secured container OS. So defense in depth. Let's say that you are making sure that a pod cannot be escaped, but tough things. If you have a CVE, and now your attacker gets an access to the host namespace. He's tried to load a very rogue module that will do something really bad on your machine. In a regular Linux machine, this will be possible, right? Because if you're not running Linux or any other mechanisms or a third-party runtime protection that sits and understands, then this can happen, and that could be a major breach. If you're using a container-specific OS, normally those will not allow you to do that because they have a mechanism to lock the kernel. Yes, it's a limitation as well. Because if you need to load a specific module, it makes things harder because you will have to specifically declare those modules and create that. But this is a very good example of how you lessen the severity of a security incident. A defense in depth. I'm running, I'm breaking from the container, trying to do something real bad, and then the OS says, sorry, no way. And not only that, those also offer the following features, most of them. So let's say that you escaped and you were able to mount from the container the root file system. In a regular image or operating system, that means that you just control the host slash. And you know what does it mean, rm-rf, and then that's it, job done. In those operating systems, normally those areas are mounted as read-only. So even if you manage to mount that, you won't be able to do anything, it's read-only. And guess what, they don't have any package manager. Who needs a package manager? Okay, I'm exaggerating. You might have specific needs, maybe NFS utils and things like that. So it's not that transparent. When I work with customers, I would say 85% of them can run those container purpose-built OSs without any blimp, because daemon sets, if you can run that on daemon set, and you don't need a special kernel module or libraries, that's it, job done. If it's a fluent bit or CNI, networking CNI, that will work most of the cases. It won't work if you need to do something specifically on the OS, or if you need to alter a read-only area, which has some mitigations that you can also do that. But if you don't have a complex custom setup, that could be a good option to increase your to lessen the event of a security incident. Again, this is not the cure to prevent attack 100%. There's no such thing. But make harder is always better, right? And I call it defense in depth. You are using Kyverno or OPA with Gatekeeper, but if someone somehow managed to escape that as well, there is another layer that is waiting for him. For example, the Linux in those, mostly in those container OSs, at least the Battle Rocket, will also mark few files, which are system files. And even if you were able to escape this root, you will not be able to delete those files, because Linux will say, I'm sorry, these are flagged that cannot be deleted or altered. So that's what I call defense in depth in multiple layers. What questions do you want to ask yourself when it comes to container OSs? Can all my target workloads run inside containers? If you can't run all the things in containers, and it means that you need to install something on the host, container OS will not work in most cases. But do ask yourself, why do I need to install something on the host? That's a good question, right? If you cannot containerize that. Do you need to install OS packages? If you don't, and this could be contained within your containers, you're OK. Do I need to support upstream OS vendors? Sometimes you might have a CSI driver that needs some libraries present on the host. That can make things a little bit more complicated, because you might need to create your own variant here. So you'll have to test and see. These are the patterns and anti-patterns. I'll just pick one pattern due to the time constraint I have. So inspired to run the same OS. That'll be my recommendation. I mean, if you decided to go with a specific distro, use it across the board. If you are multi-cloud, on-premise, etc., it's going to be very hard to adapt for each cloud vendor or area-specific OS. It's a lot of overhead, if you ask me. Or at least get there, right? You may start differentiating, but eventually get into a specific standard. And another thing I've seen with customers that are trying to go to container OSs, miraculously, they try to relax defense in-depth approach, or they try to disqualify risky security practices. Oh, I'm gonna try to bypass that particular Linux policy. Don't do that. We've put Linux there, so you don't bypass that. Everything can be bypassed eventually, right, as an operator. But if you need to bypass, you need to ask yourself why before you actually do those. Because then you most likely will lose also support for that particular operation system. Those operation systems were built with a very strict attack surface area. How many of you are divided into platform and application teams in your organizations? Cool. That's great. So this is something I couldn't solve up until, you know, and I would be more than happy to get some feedback from you. This is a major, always obstacle for my customers. Should I go for sensible defaults without restricting developer productivity? It's just a sentence here, right? But let me manifestate the problem. This is the common simplify pattern that I normally see with customers. So, platform team on the right, application teams on the left. Everything plays exactly the same. Platform team deploys the platform, and the application team connected to Git using GitOps methodology deploys the application. Yeah, we're all happy, right? We're using even Argo CD. Yeah, I'm pushing, committing. Yeah, it works, out of sync. But what happens when a new application comes and needs, for example, the following three constructs, right? It looks easy, right? Oh, let's just give it to whom? Oh my God. Should I give it to the platform team to manage that, or the developers? Yeah, and that no tool will solve you that, folks. Yeah, Crossplane can do that for you, but so let's see what happens when the platform team owns it. It adds it to maybe to the blueprints that they use, right? And then, miraculously, it's getting deployed. But it means that the application team needs to wait for the platform team here, right? And if they don't talk really well, you're in a big problem. Not only that, if they do that and the application team in the meantime deploys without those, your application is completely broken, right? And I see that quite a lot when I work with my customers. And there's no one good solution, really. You have to balance here. It really depends on your organization, even specific departments. If the application team owns that, it's probably faster, because they can use today constructs such as crossplane to declare cloud resources in a Kubernetes manner, whether it's ACK or ASO for Azure, or ACK for AWS, or crossplane with the provider. And this will move much faster than the platform team. On the other hand, these guys on the left not always understand security and a lot of other things, policies. So that opens up some platform risks. So please, make sure that they speak both of them and decide where you want to put that. But just don't obsess on a specific team that will own that. This really needs to be done deliberately. And it's not about the tool that you're using. It's about how you foster the culture here. And I'm out almost of time, so try to draw the demarcation point when you talk to those teams, right? Try to say, OK, let's draw the demarcation point here. I even have customers who decided to merge the pipelines and the GitOps methodologies to a single monolith pipeline just because they couldn't really synchronize between those particular teams. And that works, but it also has other drawbacks. So pattern, first of all, everybody needs to have a very good knowledge baseline when you go to such an architecture. And not only that, do not get into a situation where you're not defining the demarcation point. It's OK that the demarcation line will move to right and to the left as the organization gets more matured. But if you have more strict enterprise platform teams, then they should probably own that. But then they have an obligation to work really closely with the application teams, making sure that they provide them what they need. And that could be a nightmare if they're not talking or they don't have a good mechanism to share that particular information. That's the server for this session. So if you can take a few seconds and then we'll continue with the last slide. Yeah, I know that I'm on time. Just 1 minute, and I'm ending. Four questions. Really appreciate if you can. That's how I can be better for you next time, and I can understand what you really worked well in this session and what not. This is the last decision that I know I'm not going to get into, that I will not have time, but I'm really willing to. If you want to stay, I'm going to stay here for a coffee, and I can run that in, because we're not such a lot of people here. And of course, I can do a follow-up session after that. You can ping me in LinkedIn. This is something which is called the multi-cluster connectivity, decisions that I face almost on a daily basis. And I knew I'm not going to get to that, so apologize up front, but we can definitely do a follow-up on that one. And I'm going to stay here to answer questions, folks, whether on stage, outside, and exchange, LinkedIn, whatever I can do to answer any question, if I know. If not, I can think and maybe answer later. And I just want to say thank you very much for having me today here.
Also from my side, thank you so much. So you did hear it already. He's still here for a coffee. Feel free to ask. Thank you for being here. Have a nice evening, and thank you for joining the whole conference. It was so much fun. Thank you. See you next time.